So we're in your biology on chapter 10, section 2, and we're going to talk about the heart, God's handiwork. Well, William Harvey, and he lived in 1578 to 1657, was the first to describe the heart and circulation. And he said definitely the heart was from the sovereign God. The heart is probably the world's most efficient pump. The size of the heart is about the size of a fist, and it weighs about 11 or 12 ounces. The blood vessels every moment pump a blood cell 60,000 miles. Can you imagine that? And your heart beats and pumps 70 times per minute, which is 36 million times a year. The baby, actually in the womb, a baby in the womb, at 4 weeks, the tubes close into this heart, and the heart starts beating at 4 weeks gestation, just 4 weeks, until a person dies. That's how long a heart beats. Now let's talk about the design. So here's a picture of the heart, and it's kind of the external. We're going to look at the external heart first. And again, the picture here, as you can see, the heart's in the middle of the chest, and here's the lungs around the stomach down here, and here we have the heart, the center, the heart of the center, right? The center of your chest. And the heart also has this pericardium all around it that holds the heart. And this pericardium protects the heart, supports and protects. It also has membranes that lubricate. It's a very tough sac, and it has the heart slide around when it's pumped. This is the pericardium. The top of the heart, as you can see up here, branches out with these tubes. Basically, they're not tubes, they're arteries and veins. And you can see they're pipe-like blood vessels. And they carry blood from the heart to the body and back again. And then you'll see these smaller blood vessels. They're kind of yellowish here. And these are called coronary arteries and coronary veins. Coronary means heart, cardiac means heart. And what the coronary veins is, they support the heart itself. So they don't pump anything to the body, but they basically pump blood to the heart muscle, so the heart can have nourishment just like the body has nourishment. Those are those branching coronary. Now, if you had a heart attack, or you had to have someone has to have heart surgery or heart bypass, it's because usually these coronary arteries get plugged up by plaque or blood clots or something, and so this causes a problem where the heart can't get nourishment, and then the parts of the heart can die. So these coronary arteries that come in, they don't have anything to do with the pumping out of the heart, but they just supply the heart with blood and nourishment. So they're very important. So going and looking down at basically the pericardium's right here, but looking down at we're going to go into the chambers of the heart, but let's look at the heart wall. That's what we want to look at, the heart wall. And so the heart wall has four with the pericardium layers. And the outside layer is called the epicardium. Of course, cardium means heart. Epi means outside. And this epicardium is almost part of the pericardium, but it's the outside, very slippery tissue that allows the heart to move easily within the pericardial sac. And then you have the myocardium, and myo means muscle. And muscle, that's the muscle part of the heart that moves and beats. And the muscle part of the heart is the middle part. And then we have the endocardium, which is this tiny layer on the outside. It's very smooth. So because it's very smooth, it lets the blood vessels go by without getting stuck there. And so it makes it very smooth. They just slide right through. That's the endo. Endo means inside, endocardium. Myo is muscle. Epicardium means outside, and pericardium is the sac. So that the heart's in. So those are pretty important. And now we're going to talk about, I want to talk about the valves, the heart valves. If your heart valve is not working, it might back up, and then you could have problems and have to have heart surgery to have your heart valve fixed. So there's 4 valves, and it's very important that these valves work right and work right. So let's go over to here to this. Hopefully you can see this whole thing. Let's back up a little bit. It's the heart interior now. We did the exterior, now the interior. So we're going to talk about the valves. We're going to talk about the valves, but before we talk about the valves, let's talk about basically the chambers of the heart. And there's actually 4 chambers of the heart, and we'll talk about the chambers first because they have to do with the valves. So there's the left. Now, when you're ever looking at a diagram in your book, you're going to notice the left and the rights are opposite in what you think on your left and right side because you're turned the other way. Remember, looking the other way. So I always get mixed up in that. But if you're looking directly, you're going to think, oh, this is my right and this is my left, and you know that's going to be confusing. But it's actually the opposite because it's mirrored, it's looking at you. So let's go. We have the left atrium and we have the right atrium. We have the left ventricle and we have the right ventricle. Those are the 4 chambers of the heart. You'll notice that the right ventricle has a thinner outer walls, very thin outer walls compared to the left ventricle, very thick muscles, because the left ventricle is the one that's going to be pumping out through the aorta and through the pulmonary artery, pumping out the artery. The right atrium and the left atrium are just going to basically fill up and fall into the right and left ventricles. So the ventricles need that extra muscle. And so the ventricle has thick walled lower chambers there, and it's divided by an intraventricular septum that divides them, that's very thick in nature, so very muscular. And they have to have strong muscles because the ventricles are what really, really pump or squeeze the hardest, the bottom parts of your heart. And so that's pretty important. And now we're going with the valves real quick. The valves actually, you have 4 valves, and they are very important because they go from one area of the heart to the other. These are the AV valves, called AV because A, atrium, V, ventricle, AV valves. You have 2 of them, of course. And on the left side, you have the bicuspid. Cusp means flaps. So it has 2 flaps. So the bicuspid's here with 2 flaps, and it's called mitral or bicuspid, and it's in the left ventricle. The left ventricle is like the main ventricle, really, or a main part of the heart, I should say, because it's going to have to pump this out to pump all the blood out to your whole body. So this first valve here that comes down from the left atrium that goes down into the left ventricle has 2 cusps. It's the only valve that has 2 cusps. The rest of them have 3 tricuspid. So this is bicuspid, and this one on this side in the right atrium is tricuspid. They call it the tricuspid valve. So 1, 2, 3 on this side, 1, 2 on this side. So that's the two valves that come from the A to the V, A to the V. Now you have the valves that go to the arteries. And so you have 2 of those. This one here comes from the right ventricle, and it's going to go to the lungs. So it's going to the pulmonary valve, it's called, because it's going to the pulmonary. Pulmonary means what? Means lungs. So it's going to the lungs. So as you go here, you see the bluish color means that it hasn't gone to the lungs yet. So it's low in oxygen. It needs to be filled up with oxygen, those blood cells. So it goes from the right ventricle to the left pulmonary artery. So it's going to the pulmonary, going to the lungs. And then when it comes back from the lungs, it's going to come in from the left pulmonary veins here and the right pulmonary veins over on, let's see, on this side. They don't really tell you what they are, but they're coming right here. So the pulmonary veins bring it back, and it's going to go basically come in the left atrium. And pulmonary veins are going to be full of oxygen. And then it's going to go into the left ventricle. So the blood flows through the heart twice. And so now it's going to go into the left ventricle. So that's where this pulmonary valve, pulmonary valve is going to be right here for the pulmonary artery. The other valve is next to it, and it's right here, aortic valve. And you notice this, that the aortic valve basically goes to the aorta. And the aorta goes like this, comes up and around. The aorta is the big artery, and you'll see this goes to the head, your head and your arms and such, these big arteries. And then this whole artery comes down behind the heart, all the way down here to the aorta that goes down to your legs and in the bottom of your body. You know, this is the top of your body and this is the bottom of your body. So the aorta goes up to the top of your body and to the bottom, bringing blood to all parts of your body. So you see these valves. Let's also look at these valves a little closer. And I'm going to move it over here. There we go. So here's the valves a little bit closer. This is the open valve where the blood flows when it's wide open. It has 1, 2, 3 cusps, right? And it shuts and it closes it so it prevents the backflow of the blood. And so when the heart beats, it shuts. This is the valve. These tricuspid valves are on the pulmonary and the aortic. These two, one goes to the lungs and one goes to all parts of your body. Going to the lungs, it goes to the lungs to get oxygen, and then it pumps to all parts of the body after it has oxygen. And so now we have these AV, the ones I told you about, that are between the atrium and the ventricles, and this is a tricuspid. This is going to be on the tricuspid valve on the right side. So right side is 3 cusps, and this is the bicuspid, it's only 2 cusps. This is the only one that has 2 cusps, and that's on the left side of your heart, the left ventricle and atrium. And these are between the different chambers of your heart, these 2. So I hope you got all that right. It kind of gets a little bit confusing when you're thinking, but you have to see it. That's why I'm showing you the pictures. So let's go on to the next here. Going on to the skeleton. So does the heart really have a skeleton? Let's move this up so you can see better. Not really, because there's no bones in it. But when you talk about the skeleton, of course, here's the aorta, here's all of the blood vessels here, but these are cartilage. So the fibers, it has a fibrous skeleton of the heart has like cartilage, or that cartilage, or what do you say, that fibers that hold the heart together. And so here you can see again, here's the mitral ring between the valves of the left side of your heart and the tricuspid ring right there. And you can see the other 2 valves right there with the aortic and the pulmonary. And then of course all the fiber that goes right through the skeleton of the heart. So let's talk about the blood flow. So I'm going to go on with this picture here of the blood flow, just kind of to show you. Let me see, I'm going to pull it up a little maybe. There, can you see better? There we go, hopefully. So the blood flow. Okay, how does the blood flow? Let's follow this. I'm just going to go through it. You know, you can read it. It's hard to read it because it's trying to describe it, but it's better to see it. So here we have, let's say your blood is coming into the heart through your veins. So all your veins are bringing the blood back to your heart so it can be pumped. So it goes through the lower part of your body and the upper part of your body here, and it's coming in. This is a superior vena cava. Vena means vein. And this is the inferior vena cava. This is from the top part of your body, and this is from the bottom part of your body. And so it's both, as it both comes in, the vena cava, they bring all the blood in, and it rests flowing into the right, this part right here, this right atrium, the right side of your top part of your heart, the right atrium. And when the right atrium gets plumb full, and the ventricle on the bottom is only 70% full, right? So it ends up squeezing through this valve here, this tricuspid valve here. It's going through this valve and it goes into the lower part of your ventricle. when it's 70, the ventricle is only like 70% full, and so it's squeezed through there, through this tricuspid valve. And as soon as it gets in there, the ventricle gets full, the ventricle, contracts, full, like totally contracts, and this forces the blood to go to the pulmonary, and you're going up here, and it goes over to the pulmonary. So this is the pulmonary up here, the pulmonary, basically the pulmonary artery. And here's the pulmonary artery. Now, this blood here came from the body and doesn't have oxygen, so it has to go to the lungs. So pulmonary goes to the lungs. So it's going to the left lung, and it's going to the right lung over here. So it goes this way and this way, both lungs. See, it's still blue, it needs oxygen. Well, it goes to the lungs, and guess what? It gets filled with oxygen in your lungs because you're breathing, right? Oxygen in. So it goes to the lungs, and then it gets full of oxygen. It comes back from the lungs. It comes into the veins, the pulmonary veins. And as it's coming into the pulmonary veins, it comes into the left side of your heart, which is your atrium. So it comes into the atrium. So the atrium fills up with oxygenated blood. And then this blood goes through the bicuspid valve into the ventricle. So, let me get that out of the way. We just got flagged here. So let me try to get that out of the way. I don't know what happened there. There we go. Sorry. There we go. Let's go back here. Right in the middle of this, that would happen. Been having a lot of problems lately. Anyway, so here we have, okay, where were we? We went to the lungs, it came back, so it's coming back from the left lung and the right lung from the veins of the lungs, the veins to the heart, to the atrium. It goes down through the bicuspid valve or mitral valve into the bottom of your heart, which is your ventricle. Now this is this left ventricle, because this left ventricle then pumps it, bang, goes all the way up through the aortic valve to the big part of your big artery here. See right there, big artery, and then it pumps it to all over the body. So it's going up here to the upper body, but it also comes around, as you see, it curves around and comes down to the bottom part of the body too. This whole artery curves around and goes behind the heart, comes down to the lower. So it pumps it up and pumps it down to all over your body, and then all the veins bring it all the way back again, and we start over again. So I hope you got that just by looking at that little picture. But it's kind of hard to describe, but when you see it, it's pretty amazing how God's put that all together. So, and then the fueling of the heart. We're talking about the fueling of the heart over here. Let me go to the next section, see what we have. Let me see. Oh, here's another picture. Path of blood through the heart again. And this is showing the heart picture. So they have another picture here. So I'm not going to really go through this whole thing, but let's move it down. I guess it's the farthest it's going to go. Let's move this up here. There we go. See if this doesn't fall. Okay, so path through the blood here again. The blood enters the heart from the vena caves right here. We got them coming down, going into this whole section here. And so the heart, the pulmonary veins are coming in this way, but anyway, it's going this way, this direction. The heart inflated as the blood enters the atria and goes through the AV valve. So it's going through here, came in here and goes down in and goes through down into the bottom of the right ventricle. And then from the right ventricle, we go to the next. It goes, as you see here, it fills the atria, contracts, tops off, and the ventricles to the full capacity. Ventricles are, here's it coming in here, and these ventricles are just full capacity now. And then it goes from the tricuspid valve up here, and basically the AV valves close and the ventricles contract, forcing the blood out of the heart through the semilunar valves, which go, the semilunar valves as you're pumping here, as it goes into the pulmonary and then into the arteries, and it's pumping and it goes through. So here we have these hearts pumping at the same time. So you can see how they do. So that's kind of a picture. You can go over this yourself, but this is an amazing picture of how it all happens and how I went over the whole thing there. And we're going to talk about the cardiac muscle of the heart. And so what's the difference between the cardiac muscle of the heart? Let's put this up here, see if I can put it up a little easier. There we go. The cardiac muscle of the heart. We have the design of the cardiac muscle is a little different than skeletal muscle. So how is it different from the muscle? The cardiac muscle has basically has the myocardium, but it also has, you know, the skeletal muscle is very long and thin and cylinder, and so is cardiac, but the cardiac muscles are shorter than the skeleton muscles. The skeletal muscles in your, like in your the muscles of your legs and such, you know. So the cardiac muscles are short and branched, and they only have one nucleus, as you can see. And the skeleton muscles have many nucleuses, and they're connected by what these called intercalated discs. Here's the intercalated disc. Skeletal muscles don't have that. So here you have these myocardium, and here you have what the muscles look like. And you come down here, they have this cell membrane that's called sarcolemma, and then the myofibers here, and then you have a nucleus there. So you can see how it's a little different from skeletal muscles. So the cardiac muscle has to be generate a lot of, for a long, let's say generate for a long period of time. It has to last a whole lifetime, doesn't it? So, and it absolutely depends on a steady fuel. If the heart is blocked, the person will die in a few minutes or so, right? So the cardiac muscle is very, very important. So going on here, we're talking about the coronary muscle. So let's see here if they have a picture. What we have here. Oh, this is the cardiac conduction. Let's go back to the coronary. Remember the coronary arteries. So the coronary arteries, let's go back and look at them real quick. Hate to not, but I want to show you the pictures because it's best that you see where the coronary arteries are. I talked about the coronary arteries, coronary meaning heart. So here's the arteries that come in here. The coronary arteries branch at the base of the aorta, and they look like little drinking straws. And they have the coronary and cardiac veins, and they come together in the coronary sinus there to supply the heart with everything it needs for oxygen. And again, the coronary and cardiac muscle is very important. That's where the problem when somebody has a heart attack is that the heart's not getting because the coronary arteries are blocked. That's a major, major problem, right? So let's go back to the nodes here. We're going to say, what are nodes? Okay, we went over all that. So here we go. The pacemaker. Have you ever heard of pacemaker? Well, that's kind of like these nodes here. So talking about the electrical system. The heart has electrical system. Can you believe that? And the electrical system is very, very specialized. And they generate these electrical impulses that are distributed all over the heart. And it starts with a couple nodes. And right here is where, it's tiny here, see, these are all nodes, the electrical system, which is nerve system, right? Here's the electrical system, the SA node is right here. I never really knew where it was there. But the SA node is the most important. It's the sinoatrial node, and it's the pacemaker of the heart. So here's the pacemaker of the heart right there for the electricity of the heart. And it goes into what's called the Purkinje fibers. So you're going through, here's the pumping and it goes all the way down. Here's the Purkinje fibers down here. The Purkinje fibers, what are they doing? Well, the Purkinje fibers spread through the heart like electrical cables. So they're like these little electrical cables that go through the heart, Purkinje. And they carry the impulses from the SA node, this node here, to all parts of the heart. So all these little Purkinje, these are Purkinje fibers right there. They're like little, like little telephone lines or something, little fibers, like electrical cables. The SA node puts the electrical impulse, and then it races through all the Purkinje fibers. It goes to the atrium first, and it reaches them first, and then it contracts and forces the blood into the ventricles. And this AV node is the AV node bridge. So let's look, here's the AV node bridge right here, the AV node bridge to bring between the atrium and the ventricles, that bridge area. So this delays the impulse 1/10 of a second. So this basically is just how your heart pumps with the nerves. What makes it? It's the electrical system of your heart. If it goes wacko, you can end up having a heart attack. Or if it goes wacko, you can end up your heart just fluttering. There's all kinds of important. And you ever heard of a person getting a pacemaker put in? They have to get a pacemaker put in because their electrical system of their heart is not working. So instead of having an SA node, they put in electrical system to be artificially work for someone that's pacemaker is not working and their SA node is not working. Artificial pacemakers, they're surgically implanted and they're battery operated. So you have to check the batteries. They're like this small little micro processor. See if we have a picture. I don't think there's a picture of them. So anyway, so the wires are small and they put them in a hole in your vein, you know, and these electrodes are attached inside your right atrium and your right ventricle. So in your right atrium and right ventricle, they're going to be attached there with a pacemaker, with an artificial pacemaker. And a cardiologist has to put them in. What is a cardiologist? A cardiologist is a heart specialized, a doctor that specializes in the heart. And there's also for cardiovascular surgeons and such, but a cardiologist specializes in the heart. Another thing that they may take is, have you ever heard of an EKG or ECG? And this is where they put these tiny little electrode currents in, and so they can detect if your electrical system is working, right? And so they'll put it on your legs and your arms, these little electrodes, and then on parts of your heart, so they watch if there's any unusual rhythms for your electrical system in your heart. Electrical system in your heart is very important. If it goes wacko, your body's gonna go wacko, your heart's gonna not work. So the heart at work, let me see here. I'm gonna stop there and then we'll go on to your heart at work and just some of the things that go wrong in your heart.